So what we're being asked to do here is to convert the logarithm into an exponential. So we're going to be following this kind of formula, if you want to call it that. This is how we convert between a log and an exponential. So our base b is raised to the y power, and it's going to equal x, which is a number inside the parentheses. Now sometimes the parentheses are not given there, but they are in this case. So we'll look at number 1. We have log base 7 at 2401 equals 4. So even though it's not shown there, it's like they're in parentheses here. We want to take our base, which is 7, raise it to the y power, which is 4. And we're going to set that equal to the number inside the parentheses, which is 2401. So for number 2, we're going to do the same thing. We take our base, which is a small subscript number, in this case 1/2. Now you can write the fractions in parentheses, that's typically how you want to do it. We're going to raise it to the exponent, which is the number by itself, in this case -5. And that's going to equal the number that would be inside the parentheses, which in this case is 32. Oh, there's 2 number 2's. So this number 2, we take our base, which again is 5, the small subscript number. We raise it to the exponent, which is over by itself. I'm going to set it equal to what's inside the parentheses, or where they would be, which would be here. The 390,625. And then same thing over here with the log 121 of 11 equals 0.5. We take our base, which is 121. We raise it to our exponent, which is 0.5. And we set it equal to what's inside the parentheses, or what would be, in this case, 11. Alright, so here we're going the opposite direction. We're going from exponential to logarithm. So our base is going to be the small subscript of the log. The exponent is going to be on the other side of the equal sign by itself. And the number that's by itself is going to become inside the parentheses with inside the log. So we want to start these out by writing the word log. And then we're going to put our base, which is the base of the exponent, in this case 8. And then we'll put some parentheses. Now inside those parentheses is going to be the number that's by itself. So in this case, 262,144. And we're going to set that equal to the exponent. Okay, we're going to do the same thing for number 6. Start out with the word log. Our base here is 3, so that's going to be the small subscript number. Now inside the parentheses is going to go the number on the other side of the equal sign by itself, in this case 81. And then we set that equal to our exponent, which in this case is 4. Number 7, same thing. Start out by writing the word log. This time our base is 20. And inside the parentheses, we're going to put the 160,000. Oops. Because that's a number by itself, so that goes inside the log. And we're going to set that equal to our exponent, which is, in this case, 4. So then the last one on this one is we have log. We're going to keep our base, which in this case is 10. Then inside the parentheses goes the number by itself, in this case 1,000. And we're going to set that equal to our exponent, which is 3. Now this is also a special case of logs because it has a base of 10, so this is what's called the common log. So anytime that you write a log with no base, it's assumed that the base is a 10. So this one could also technically be written as log of 1,000 equals 3. So either one of these is correct. Okay, so on these we're being asked to evaluate. One thing you could do is you could always type it in the calculator. But basically what this is saying is 5 raised to what power gives us the 25, the number inside of the log. So what we can do is we can take the log expression, set it equal to x, and now we can convert it to a log. So we take our base, we raise it to our exponent, and we set it equal to what's inside the parentheses. So we want to know 5 raised to what power gives us 25. Well, if we go back to what we did previously, we could change the 25 and we could rewrite that as 5 squared. So we have our bases the same, so x is 2. Okay, so number 10, we have log base 2 of 32. So again, we want to set this equal to x. So if we write it as an exponential, we have 2 raised to the x power equals 32. So we want to rewrite 32 to have a base of 2. So if you don't know what power you need to raise 2 to, you can always do a factor tree. So there's 1, 2, 3, 4, 5. So 32 can be written as 2 to the 5th. So now since our bases are the same, we can ignore the bases, and x is equal to